In this video, we will be learning the formation of the Philippine archipelago, how it was formed, and the processes on the and the processes that made the Philippines. Now, currently, this is how the Philippines looks like. Okay, just look at this picture here. Okay, this is an archipelago composing of more than 7,000 islands, and then they all vary in sizes. Okay, now the red parts are the highest points in the Philippines, and the yellow and the green parts are the the lowest points. Okay, so this is how Philippines looks like right now, and let us learn on how did it become like this. How did it form into this archipelago? Okay. Oh, first, before we can learn how the Philippines was formed, we need to learn about plate tectonic. It is a very famous and it is a very fundamental theory in knowing more about the earth, the movement of the earth, earthquakes, volcanoes, and lots more. But technically, we can learn plate tectonics in the formation of the Philippines. Now, currently, the earth is divided into all of these tectonic plates. Okay? As we all know, the earth has many layers. And these are all the these plates, okay, are all moving independently from each other. So, let's see and let's learn about this. Plate tectonics is wherein the Earth's layer is made up of large moving pieces called plates. So these are the plates. Now these plates, they move, and according to the theory, all of the Earth's land and water sit on these plates, and these plates are made out of solid rock. They are all part of this layer called the crust. Okay? This layer called the crust. These are all plates. They move independently from each other. The crust is breaking. These are like puzzle pieces. Okay? They crack and then they break. Now, let's do a quick review about the layers of the earth. We have the inner core, we have the outer core, we have the mantle, and then we have the crust. Crust is, of course, the thinnest layer. Okay? The crust is the thinnest layer, and this here is what is composed. This is what makes up the plates. All of these plates over here. Another portion of the theory says that under the plates is a weak layer of partially melted rock. Now that layer is called as the asthenosphere. This here, okay? The under the plates is weaker layer, partially melted rock, and the plates are constantly moving over the weaker layer. Now this layer over here is where the asthenosphere sits, and then there is also a process in the mantle wherein convection current happens, wherein heat circulates around the mantle. Now when the heat circulates in the mantle, it heats up this layer over here called the asthenosphere, thus making the very thin crust move. Now let's look at this other video over here. This here is a more updated version of how heat from the inside of the earth is moving towards the asthenosphere and towards the crust. Okay, all of them are happening inside of the mantle. So imagine it like this. The asthenosphere is a very movable, it is a very ooey gooey place. It is filled with molten rocks. The asthenosphere is currently the source of the heat circulating around the entire layers of the earth. It melts the asthenosphere, and because the asthenosphere is melting, the solid crust rides along with the asthenosphere. So it is just like whipped cream. The asthenosphere is whipped cream, and then the crust is your graham crackers. And the graham crackers are moving along the whipped cream. And the cream is really, really creamy because of the heat that comes from the mantle. Okay? And because of that, all of these tectonic plates are moving in many, many ways. The African plate is going here, going there. South American plate is going here. The Philippine plate is going there, the North American plate. And all of these movements, all of these plates are moving around because of the activity that's happening here in the mantle and the activity that's also happening in the asthenosphere. Now, this here is a quick, a theoretical way of going back millions of years on how the entire world looked like before the continental drift, as what the theory would say, before everything, uh, tracing back to where all of these tectonic plates came from. Okay? And this here is how the tectonic plates look like right now. And until now, they are still moving. Okay? Another thing to take note, there are three ways on how these plates move. They collide with each other, which is called a convergent boundary. They diverge with each other, which means they go away from each other. And then they slide past each other, wherein they horizontally just slide. This one is going front, and this one is going back to this slide with each other. So they converge and they diverge and they slide past each other. Now, a good thing to take note is about these two over here, the convergent boundary and the divergent boundary. Why? Because these two boundaries mainly create landforms. Okay, so what you can see here, a convergent boundary can create a mountain range. Okay, this here can also create islands. It is like, you have one plate here. This here would be, let's say this is brownies, and then the other one is also brownies. When you would lay them flat, they would be flat. But when you push them towards each other, at the boundary of your two brownies, there will be, this part will ascend and it will rise up. That is how mountain ranges are also formed. Now imagine if this was all underwater. Okay, and this here would, if the two plates would converge, your two brownies would converge, this part over here will go above the water, thus creating a series of islands. And that is how exactly how the Philippines was formed. Now, a good thing to take note is that the Philippines was made by the interaction of the Eurasian plate, the Philippine plate, and of the Pacific plate. We can all see them here, the Eurasian plate, the Philippine plate, and the Pacific plate. The main movers here is the Philippine plate was colliding with the Eurasian plate. Also, some of the push coming from the Philippine plate also comes from the Pacific plate. So let's look at this animation over here. Okay, over 55 million years, the interaction between this here, the Philippine Sea plate, this here is the Pacific plate, and then the Eurasian plate. Okay, look at the movement of all of these plates, giving rise to the Philippine archipelago. Okay, convergent boundaries, creating islands and bigger and bigger and taller and higher islands. So let's see that all over again. About 55 billion years ago, the tectonic plates were moving, influencing all of this area over here, creating independent islands and archipelagos. And after millions more of years, the Philippines then became into what it looks like right now, into this archipelago. And that there was how the Philippines was created. In this video, we started discussing about plate tectonics, how the earth was separated into different types of plates, and these plates are part of the thinnest layer of the earth, the crust. We also discussed that in the mantle there is interaction that's happening, that the asthenosphere, a molten layer, is the influencer in why these tectonic plates are moving. And we also discussed that these tectonic plates are going in different directions, and the boundaries of these plates, they can collide and then they can diverge and they can slide past each other. We also discussed that as plates collide, the area where they collide rises up, and also we also discussed that this was the reason why the Philippines archipelago was created. It was also created by the interaction of the Eurasian plate, Philippine plate, and Pacific plate. And in this process took millions of years because every single year tectonic plates move from 2 to 10 centimeters a year. And this movement is thousands of kilometers. The interaction between the Asthenosphere, the crust, the Eurasian plate, the Pacific plate, and the Philippine plate is what made the Philippine archipelago.